Hi everybody, Dave here again, and today's model is the Madcow Rocketry Viper, and this is one of what they call a warehouse kit. This is actually all that comes in the kit here. Now this is a fiberglass rocket, and you'll notice here I'm wearing gloves, and the reason for that is any place that there's a rough area on here, individual glass fibers can be coming off that, and that gets into your skin, can be itchy and painful and generally a nuisance. So when you're working with fiberglass, I recommend wearing gloves all the time. When we get into the point where we have to sand or file this, you'll also want to wear a protective mask. And so when we get to that point, my voice may seem a bit muffled because of that. This is kind of a step up. The principles of building here are the same for most model rockets, but this is heavier, and instead of white or wood glue, we'll be using epoxies. Now there are a lot of fancy rocket epoxies out there that are often sold specifically for doing fiberglass rocketry. They work fine, but also the common household epoxies you can get at a hardware store or a paint store, those are going to work just fine here as well. Now the first thing we're going to need to do is remove any of the dust and also the mold releasing materials that were used in the manufacturing process. And for that, I made up a fiberglass washing solution. And this is made up mainly of rubbing alcohol and water. To make your own, take 1.5 cups of water, add 1/2 cup of rubbing alcohol, and it can be either the 70% or the 91% type, either one's fine, and then add just 1 drop of dishwashing liquid and then mix that up really well. And all this does is make a solution that will dissolve both water-soluble and non-water-soluble types of material that might be on here. And I just put this onto a paper towel, and then simply just wipe this over each fiberglass part here. Okay, again, there's not usually a whole lot to clean off here. But the powdery residue, and sometimes there's a greasy residue, will interfere with the adhesion of the epoxies that we use, as well as the paints. And also they just get everywhere, so you don't want that fiberglass powder in your clothing and such. Okay, and then just change paper towel there. You could use a reusable rag or something here. But if you're going to do that, make sure you wash them separately from the rest of your clothing, or you may end up with fiberglass in there. Okay, so I'm just going to go ahead and do all of these, and then we'll come back and start piecing stuff together here. I've washed off all the parts, and now I want to just go through this really quickly. As I mentioned, the Madcow Rocketry warehouse kits are pretty simple and basic here. They just include the fiberglass parts. And so you may notice here there's no eye bolts, there's no shock cord, there's no parachute. You need to provide all of these yourself. Okay, this is actually a mid-power kit. This is the motor mount here, it's 29 millimeter. It is theoretically possible for this to be run with a high power 29 millimeter motor. However, once we get this all put together, that motor mount takes up almost half of the kit, or the body tube, excuse me, and the other parts, the shoulder piece for the nose cone and such, come down to about here, and this doesn't leave a whole lot of room left for a parachute and shock cord and everything. And an H power motor will actually extend about that far past the motor mount. Okay. Now throughout this, I'm going to talk about different options that you could do with this, and For this reason, this is definitely not a starter kit, although it's a great kit if you've never done fiberglass before. But you already want to have some knowledge of what goes into a rocket and what you can do to a rocket safely to change some of its interior layout. Okay, so I'm just going to go through this really quickly. We've got our body tube here. It is pre-slotted. The nose cone, fairly long. It's an ogive nose cone. According to the Madcow Rocketry site, this has what they're calling a composite tip over the fiberglass here, and I think all that means is they made it with epoxy. The entire tip of this thing is filled with epoxy, and it looks like they ground that down there. As I said, this is the motor mount. We have 2 fiberglass centering rings. This is a coupler. Now you may notice that there's no shoulder on this fiberglass nose cone, and this slides in to form a shoulder. And there's quite a bit of it down here. And this is one of those places where I say there's a lot of room that already gets taken up. So if we put that next here in our motor mount, we've only got about this much space for everything else, including the parachute, shock cord, hardware, and other such things. And this is why I say that although technically you could fly this on an H motor, you may have trouble getting the actual motor inside with everything else there. Alright, then we have a bulkhead, and this will be glued to the back side of the coupler here. And then 3 pre-cut fiberglass fins. Something I've found on the fins, if you look on the Madcow Rocketry site, they do have an illustration of this rocket completed, and in that it shows that the fins mount so that the back edge of the fin here is flush with the body tube. But when we line that up with the slots, the tab here of the through-the-wall fin mount is too long in this direction and too short down here, which here's one of those options that you'll need to consider what to do. So one possibility is that you could extend the fin slot here by filing some of this away. You could also cut away some of this fin tab so that it does fit in the correct place. So if we cut off about 1 centimeter of its length, or you could assemble it as it is and actually have this part of the fin sticking down. From a stability point of view, this is actually better than having the fin up here. However, having the fin up here makes this less likely to get damaged if it hits hard. Now, being fiberglass, this is going to be much more resilient than the common balsa fins that you'd find in lower power model rockets, or even hardwood or plywood fins of the same thickness. And so this is less of a problem having a chance of breaking a fin off than it would be in, say, a balsa fin. Okay, so that's something to consider as you're putting these on. All right, I have already put this together in silico, in simulation, and one of the other problems with this is that as it's laid out here, and even once you get the take account of the hardware that's going to go in, the shock cord, the parachute, all these things, there's still not enough mass in the nose to make it stable. If you put this kit into RockSim or OpenRocket the way it is, it's either neutrally stable or even just slightly negatively stable. And so I found that, according to my simulation, we need to add about 100 grams to the nose cone here up in front. And one way to do this is to take some lead shot like you'd find in a fishing department or in the hunting department if you find a place that does reloads. You can put that in and then overcoat it with epoxy. But Some of the other options we'll talk about here, including the possibility of putting an avionics bay in the nose, will also alter that. So one of the things that I really recommend is don't permanently assemble anything in the nose until you are completely done. Okay, so go through and get everything attached, get all the pieces in, whatever optional gear that you put in for hardware and recovery, have that all in, and don't glue this together until everything else is done. Because that way you can check the center of gravity on this, run some simulations, and find out just how much mass you're going to need. For this part, I've put on my mask because we're going to need to do some sanding or filing of the slots here. If we try and dry fit our fins, they're just a little bit thicker than these slots are. And so I'm going to take a file here I'm using a very fine modeling file. You can find these at most hobby stores in a nice set. But this is going to take just a little bit of filing on each edge. I am not going to record all that because it's going to be really tedious, so I'm going to finish doing this and we'll see how the first fin fits. That didn't take long, just a minute or two. But now I've widened this slot a little bit, and now I can put my fin in. Okay. And again, you're going to have to decide where you want your fins. I've decided I'm going to go ahead and put these as far back as I can because that's going to give me the most stable configuration, and that will lessen the need for as much nose weight later on here. Okay, so that fits in really nicely that way. And now I'll just do the same thing to the other two slots, and we'll dry fit the other fins. I've opened up the other two slots now, and we've got a little bit of residue here. We'll clean that up in a moment. Now we'll just dry fit the other two fins. Okay, so you want those to be snug, because that way the more contact you have there, the less dependency we'll have upon the adhesive, the epoxy here. All right, and if we look down through it now, the fin tabs are on the inside, and this is what's going to, in part, reinforce everything. Okay, because when this is all finished, the fins, well, hard to show that without actually having it in place, but the fins will actually glue onto the motor mount inside here, and then we'll also put epoxy fillets on the side. So this will make the bonding of the fins to the tubes very strong. Now when we get to actually putting the epoxy on here, one of the things we'll want to do is roughen up the surface a bit. All right, the smooth surface that we've got makes it really easy to paint and such, but there's nothing for the epoxy to hold on to. And so we'll just roughen up the surface here where the fins are going to go, and there's no real reason not to roughen up this whole thing really, because you're not going to be coming in contact with it. But I will just for the sake, because fiberglass drives me nuts, I'll just roughen up here where the fins are going to attach the inside there. It does mean we'll have to make sure of the alignment once that goes in. And also when we're ready to do this, we'll roughen up the area just along the fins here. So wherever that fin's going to be, we'll just roughen up a line so that the fillets also have a good place to hang on to. And on the fins, we'll roughen up the area, especially along the edges here where the fillets are going to be, and also where we glue it internally. Alright, so our next task is to check the fit of the centering rings on the motor mount tube. And as we can see here, they are not going to fit like this. We do have some residue you can see here inside from the manufacturing process. This did not get cut completely out. And so like before, we're going to file this out until we get it to the point where it fits here. And then we'll also need to check and make sure that they fit inside the body tube, which they do just fine. So I'm just going to have to do a little bit of filing around the insides here of our centering rings. And once again, I'm wearing a mask doing this. I'm going to use a little bit different file that has a rounded edge. This one is flat on both sides. And then we'll go ahead and file that out and try fitting this together again. There we go. Alright, so I'm just going to make sure I can pass this all the way through. Twist back and forth here. Okay, so this is the first one. I'm going to do the second one off camera because that was tedious enough the way it was. And when we come back, we'll put both of them onto the motor mount tube and see how it fits into the body tube. These are some examples of the eye bolts that would be used in a high power rocket. In fact, these are from another Madcow kit. But if we were to put these in here, one is we'd have to drill a hole through more than half of the total width of this ring. That'd be a really big weak point. Probably actually wouldn't be a problem here once we get all the epoxy and everything on it. Okay, but we'll probably want to go with something smaller. And so you can get these at hardware stores, and I would look for one that's about 1/8 of an inch in diameter rather than 1/4 inch. If they don't have it in fractional inches, probably about a number 10 screw and eye bolt there. Something else that's not included with this kit is any type of rail assembly or launch rod assembly. So you're going to need launch lugs or rail buttons here. And in this case, I would highly suggest rail buttons, just because this is going to be a somewhat heavier rocket. And also, you're going to get a better connection between the screws or bolts of the rail button and the fiberglass than you would by trying to put an actual launch lug on here. Okay, these are standard rail buttons here. Again, these came with another Madcow kit that was not one of the warehouse kits. And so that's going to be something else you'll need to consider at this point, because if you are using rail buttons, the placement of those is also going to have some dependency upon where your motor mount is and where the other things that might get in the way are going to be. Now, before I go heading to the hardware store to get eye bolts and such, we also want to take a look at the nose cone and some of the options we have here. So apparently the intended way to do this is to glue this coupler into the nose cone and then glue this bulkhead onto the end here, and that would make it flush with the coupler. And before doing that, you would need to put an eye bolt in here and mount it with its hardware. Alright, so this is drilled for a 1/4 inch bolt. or eye bolt. Okay. The problem is it seems like a huge waste of space there that could otherwise be used for electronics or a payload, or even if you just need to get access to it to change the nose weight depending on the stability of this. And so my idea is to use some threaded rod. Now this is a little bit narrow, I'm going to have to get a bigger one, but this would fit down inside the tube. Okay, and this is with the coupler on, so that sticks out a fair amount there. And then we could put the bulkhead here on it and simply screw this down with a nut. Now what we need to do is epoxy the end of the threaded rod down in here, probably a depth of at least 2 centimeters. But that would give us now first some more weight in the nose, but also it gives more options, so that if I just want to use this as a nose cone as is, it's fine, because the threaded rod will still hold everything together. If I later on want to put in a sled for an avionics bay, I could build one that would work using just a single threaded rod. Now a lot of them use 2 for stability, but if you already know how wide this is going to be, a single rod will still work quite nicely. Okay, so one of the things I'm going to get besides eye bolts at the hardware store is some more threaded rod of a little bit thicker type there, and I think that'll give me the most options on the nose cone here. Now if you take the threaded rod approach, we will have to consider one other thing, and that is how we'll actually mount the recovery system to the nose cone. And there are a couple of ways that you could do this. One is to get a threaded coupler that would screw down here on one side and then allow another screw to go in the other side of the correct dimensions, of course. The other possibility would be to take a U-bolt and go across here. Now to do that, you're going to have to make sure that the U-bolt will go over the threaded rod here, or you'll have to mount it off to one side a little bit to make sure that the parachute harness and hardware and everything else will still fit properly with that in place. I've returned from the hardware store, and what I came up with then is a 1-foot section of 1/4-inch threaded rod here, and I just bored out the hole a little bit more on the bulkhead so this will move freely through it. And my intention then is to put this down into the nose cone and add a goodly amount of epoxy in there to hold it in place. And to do that, we'll also have to have this put in. Okay, so that when this is standing up like this and the bulkhead is on, that will hold the rod in a more or less straight position. It should be pretty close. And then I've got a coupling nut here and a 1/4-inch eye bolt. Now the shank of the eye bolt may be a little bit too long, and that'll be easy enough to cut down. But this will simply fit on the end like this. And then the eye bolt will go in here. And now if I need to take the whole thing apart, I can just remove the eye bolt. And I'll probably want to use a little bit of thread lock on that just so it does not come out during flight. Okay, and then if we remove this, if the bolt's epoxied into place, then I've still got full access to the nose cone. The coupler here does not need to be glued in place. And this means I could later on put if I wanted to, an avionics bay into this, or if I need to change the amount of nose weight, it's very easy to get into it this way. So I'm going to mix up some epoxy and put it down in there and set this up in just a moment. Right, so I've got the nose cone inverted into the body tube as a stand, and putting in here about 15 to 20 milliliters of 5-minute epoxy. This is going to add about 20 grams to the nose cone. And so if we have that in addition to the hardware we're installing here, we may get to a point where we actually don't need any extra nose weight, which I prefer. I don't like to add weight to the rocket if I don't have to. Okay, so this is just starting to set up. And I want to make sure I did not get any where I don't want it there. So I want it all down in the bottom and not going down along the sides there. And I'm just going to take a tissue and make sure. Oh, yeah, there was a little bit there, so we'll get that out. Unfortunately, the nose cone only goes down about 2 to 3 centimeters in that. Or not the nose cone, but the coupler. Okay, so that should be okay there. Okay. So everything looks safe. Alright, so I'm going to stick that in. Now, I'll go back to using that as a stand, but to illustrate what I'm doing here now. So now I'm going to stick this down inside. And that looks like it's covering it at least, let's say about 2 centimeters there. And the good thing is, if we need to, we can come back and add more epoxy to this. Alright, and so now I'm going to prop this back up on the body tube, and I'm going to let it cure overnight before I do anything else to the nose. Also, while I was at the hardware store, I picked up some smaller eye bolts. These are number 8, and this I'll use to put into the forward motor mount ring here, the centering ring, and this will be the attachment point for my shock cord. Now I am planning to use 1,500 pound test Kevlar for this rocket, mainly because it doesn't take up as much room as tubular nylon does. And so just to test fit here, I'm going to put a washer on, and then this will go through. I drilled a 5/32 inch hole in there, and then this will go on. Now I'm going to need to cut a lot of this bolt off, because there's really no need to have this much left, and that's just extra weight in the tail. And if there's one place we don't want weight, it's in the tail section of the rocket. Okay, but that's about how it'll look there. Okay, and then we'll put this on like such and insert it into the body tube when we're ready to do both the motor mount and the fins. Okay, now one thing we will have to be careful of is to make sure that this part is set between 2 fins so that we don't end up with a situation where the screw here might block the fins. And that's also a reason to cut it down. So this is what it looks like with most of that shank cut off. Now that will go on here. Now when we actually put all this together, I will put some epoxy both on the washer side here and on the nut side, and then within the threads here so it locks this nut in place. But I don't have any epoxy left, or do I? Nope, it's already hardened. Okay, so the stuff I just used to do the nose cone is hardened already, so I can't use that. And it's not worth making up another batch here until I'm ready to put this all together. What I'm doing now is marking a point halfway between two of the fin slots here so that I know where to put the launch rail buttons. So we've got 6 centimeters here, so I'm just going to mark this at 3. Okay, and then I'll make another mark up here, also at 3. And those are actually going to be fairly close to where I'm planning on putting the rail buttons. But now I'm going to put this against a straight edge here. Easier to do it this way. Okay, I'm just going to line those up. Looks like I was not completely precise on those markings, but this will work anyway. Okay, so now I've got a line all the way up, and I can use that to put the rail buttons on. Okay. The other thing we need to start doing is prepare the surfaces to receive epoxy. And on the body tube itself, we just need to do a little bit right around where the fin slots are, because we'll have some epoxy fillets that will go on the sides. So I'm just going to take some medium grit sandpaper here and make sure that you are wearing safety equipment for this part. So gloves, safety glasses, and a filter mask. Right, and now I'm just going to wipe that off with a few tissues, moisten that with a little bit of rubbing alcohol. You don't need to use rubbing alcohol, it just evaporates quickly. I'm just using this to pick up the residual dust. Alright, and then we'll need to do the same thing to the engine mount tube. So for the motor mount, we can actually rough up most of this because we'll need to have some surface up on the forward end for the retainer rings, and one on the back end for the retainer rings and for the engine retainer that'll go on here. And then we'll also do just right around the insides here of the centering rings. So any place that epoxy needs to stick, we need to rough up. Now that I have my surfaces roughed up a bit here, I'm going to go ahead and do a little more test fitting. I'll put a fin in here so that we can see where the tab actually comes in here. And then if I set this up against it, I want the aft end of my motor mount to protrude about 1 centimeter here, so I've got room for the engine retainer to go on. And what I want to have happen here is have a centering ring in place so that it's just forward of the fin tab there, and that'll give some additional surface for the epoxy to bind to. And as I mentioned, I think what I'm going to end up doing here is putting on a total of 3 rings. 2 of them forward, alright, so that one will be here right in front of that fin tab there, and then this one at the very forward end of the motor mount, and then I'll get a 3rd ring, and these fiberglass rings can be purchased from a variety of rocketry outlets. I know Madcow, which made this kit, also sells individual parts like this, and I've got some ordered. The idea behind this is if I have 2 rings on here, I can set this in once they're glued without gluing on the last ring. And what this will allow me to do is get inside the airframe here. When I'm ready to start gluing the fins, I'll actually have room to put internal fillets from the fins and onto the motor tube here. If I only have 1 ring on there, I can't make sure that my engine mount is centered. But if I have 2 rings, then that'll hold it in place. And I can actually put a 3rd ring on without gluing it. Once I've got all of my epoxy on, I can just leave that there to help hold this in the exact center, and then remove the ring, add my final bit of epoxy, and then glue the ring in place permanently. Okay, and then for my rail buttons here, I think what I'm going to end up doing is, at least for the forward rail button, once I've got the motor mount in place, instead of using the machine screw that came with these buttons, instead I can use a wood screw of about the same size. And what I'll do is drill a hole through the airframe and into the edge of one of the centering rings here, and then I can screw in the wood screw, bring that back out, put a little epoxy in it, screw it back in, and that should be a pretty permanent type of mounting. Although if you really need to, you could probably force the screw open again if you need to replace one. Alright, so I've made up a little bit of epoxy here. And I'm going to put these rings on just one at a time. I want to let them set up each time so that I can go back and check them against the fin alignment and such. So I'll make sure that they fit where I want them to within the body tube and in relation to the fin slots. Alright, so this part is going to go up near the forward end here. So first I'm just going to put a thin layer around this, and then when I push this up, it's going to form a fillet in front of it. Okay, so I can move that upward. I'm going to allow this to sit and cure for a little bit here. Now the other thing I'm going to do while I've got the epoxy ready is take the little eye bolt that I've got here, and I did cut off a piece of this so it's not as long as what came from the hardware store. And so I'm going to run this through. I've got the washer on top. I'm just going to add a little bit of epoxy around the threads. Also put just a little bit here around the hole. And I'm just going to slide this in. Now I was debating whether or not to actually do this before I glued the centering ring on. Which might be easier, although it'll make it try to roll over while you're gluing. But it's going to try that anyway. So if I could do this whole thing over again, I'd probably put the eye bolt on first. Okay. While I'm waiting for the epoxy to harden on the motor mount, I'm going to go ahead and prep the fins here. And what I need to do is roughen up the surface here in the fin tab, and also just a little bit up in here. And then I also need to, I'm just going to take the edge off these. They're fairly thin fins, so if I put a knife edge on here, it will actually be a knife edge. It'll be really sharp and potentially dangerous. So I do want to smooth this over a bit, but I'm not going to work too hard on actually making an airfoil here. Okay, so that's about it there. As I said, I'll probably have to take a little bit finer sandpaper and smooth out the edges here a bit more. But I'm going to stop this here and do the other two fins, and we'll come back when I'm done.